Brought to you by Thomas Allgaier and Frennis. This edition highlights key LinkedIn posts on next-gen vehicle intelligence in weeks 19 and 20. Frennis supports Tier 1 automotive suppliers with early-stage market validation for their R&D efforts by combining secondary research, direct OEM expert interviews, and facilitated customer meetings. You can find more info in the description.
Imagine driving a 2-ton computer at 70 miles per hour, and literally the only thing keeping you from a catastrophic crash is just one single line of code.
It's a terrifying thought, honestly.
Right. Well, welcome to the deep dive. And if you're joining us, you know the mobility space is moving incredibly fast. The stakes really have never been higher.
Yeah.
Today, we're looking at what the engineers, the strategists, and the developers are actually saying on the ground.
Exactly. We're extracting the most critical insights from curated LinkedIn content across the industry. And today's journey covers a lot of ground. We're going to explore how AI is completely redefining the cockpit experience.
Oh yeah, the dashboard is totally unrecognizable these days.
It really is. And then we'll lift the hood to look at the underlying software architecture making that possible.
Because the hardware just isn't the star of the show anymore.
Right. And finally, we'll get into the massive challenge of validating it all. So these vehicles are actually safe to operate. Okay, let's unpack this, starting with the cockpit. Because to really understand where vehicle intelligence is heading, we have to start right where the human meets the machine.
Yeah, the dashboard is undergoing a massive identity crisis right now. I mean, it is no longer just a digital speedometer or like a place to tap your radio presets. It is becoming the primary interface for an entirely new kind of computing platform.
We all remember the dark days of early voice commands, right?
Yeah.
You'd be screaming, "Call Mom!" 4 times at your steering wheel.
Oh, man. And the system would somehow end up dialing a local pizza place instead.
Exactly. I've definitely been there. But looking at recent posts from Inabihi Ufo and Wassim Ben said about the new Rivian Assistant rolling out to their R1 vehicles, we are light years past that. And they made a really crucial distinction here. This is not just phone mirroring.
Right. It's not just Apple CarPlay or Android Auto.
Exactly. It's not just projecting that onto a piece of glass. This is a native AI agent built directly into the vehicle's operating system.
What's fascinating here is the fundamental industry shift we are witnessing from the software-defined vehicle to the AI-defined vehicle. Sri Subramanian posted an excellent breakdown of this.
Oh, I saw that one. He talked about multimodal systems, right?
Yeah, multimodal and agentic systems. Multimodal meaning it can process voice, visual context, and sensor data simultaneously. And agentic meaning, well, it has actual agency. It doesn't just wait for a rigid command. It can reason.
So it's not just turn on the AC.
Right. You can tell a system like Rivian's to, say, move a meeting on your Google Calendar, navigate to the new location, and text your ETA all in one breath.
Wow, so it actually understands the context of the cabin.
Exactly. The AI understands the context and executes complex, multi-step workflows.
You see different automakers taking slightly different paths to get there, though. Take Mercedes-Benz, for example.
Oh, yeah. They're going heavily into the enterprise space.
Right. Marcus Gobel shared a great interview with Magnus Østberg, the chief software officer at Mercedes. Their approach is essentially turning the car into what they call the third workspace.
Which is an ambitious label.
It is. They are natively integrating Microsoft Teams, ChatGPT via Azure OpenAI, and Intune.
And for anyone who hasn't spent time in enterprise IT, Intune is basically Microsoft's corporate security tool. It lets a company manage and secure your data remotely.
Exactly. So Mercedes is building a system where the digital transition from your office desk right into the driver's seat is completely seamless and corporately secure. But I look at this and I have to wonder, is this really the leap forward we think it is?
What do you mean?
Well, are we just bolting an office cubicle and a smartphone onto the dashboard? It feels like we might just be distracting the driver with better productivity software instead of fundamentally changing how the car operates as a machine.
I mean, that is definitely a trap some automakers are going to fall into, just slapping a tablet on the dash and calling it a day. But the leaders are going much deeper than just an infotainment overlay.
Like who?
Well, to see the difference, look at the recent Beijing Auto Show. Guang Yang highlighted a really revealing demo from Sense Auto. They showed an in-car AI agent tied directly into the vehicle's physical sensor suite.
Wait, tied into the physical sensors. How does that work?
Yeah, so a driver used a simple conversational voice command to search through their dashcam history. They just asked the car to show them the video clip of a near miss at a specific intersection.
Oh, wow. So no scrolling through submenus or checking timestamps?
None. The AI understands the semantic context of what a near miss looks like, searches the vehicle's memory banks, and pulls the exact clip. That is contextual companionship.
Because it's an active participant in the drive.
Exactly. The AI is aware of the car's physical environment, its history, and its sensor states.
But, if you want a car that can instantly pull dashcam footage, understand traffic patterns, and process your calendar seamlessly, you can't run that on a fractured, disconnected computer system.
No, absolutely not.
You need a unified nervous system, which brings us to the actual architecture and how these companies are organized.
Yeah, and Aniruddha Dorliani posted a brilliant application of Conway's law to automotive engineering to explain why this is just so difficult.
Remind me, Conway's law is about organizational structures, right?
Spot on. It states that organizations design systems that mirror their own communication structures. Legacy vehicles ended up with over 100 separate isolated electronic control units, or ECUs.
Because traditional automakers had completely separate departments.
Exactly. The powertrain department didn't talk to braking, and braking didn't talk to infotainment.
It's like trying to build a world-class symphony orchestra, but locking the string section and the brass section in two different buildings, giving them different sheet music, and hoping it sounds good when they finally play together.
That is a perfect analogy. If your company is siloed, your car's brain will be siloed. You simply cannot build a unified, centralized, software-defined vehicle with a hardware-defined, siloed organization.
The company structure actually has to change. And the architecture itself is going through a massive evolution right down to the fundamental code being written. Like Satya Pradhan's post about the silent shift happening in the industry from the programming language C++ to Rust.
Oh, that's a massive shift in the industry right now.
Right. And he made the point that this isn't just some trendy developer preference. It is a critical safety architecture decision. C++ has been the industry standard for decades because it allows developers to build really fast, efficient software.
Very fast. But the downside is that it leaves the door open for memory leaks.
Exactly. Memory leaks and buffer overflows that only show up at runtime, meaning while the software is actually operating. In a laptop, a memory leak is an annoying crash. In a vehicle moving at highway speeds, a memory error affecting the braking system is a catastrophic safety failure.
Yeah, and Rust solves this by eliminating memory safety risks at compile time. How it does this is really clever, actually. Rust forces strict ownership rules on every piece of data.
So it won't even let the code run if it's flawed.
Exactly. If the code isn't perfectly memory safe, the compiler literally refuses to turn it into an executable program. The bugs are caught before the software is even allowed to exist.
That's incredible. But having safe, bug-free code is only half the battle, right?
Right. If we connect this to the bigger picture, it is all about how these disparate systems integrate continuously. Marcus Retstadt brought up a great point regarding Eclipse S-Core and AUTOSAR.
And for those who aren't deep in the weeds, AUTOSAR is basically the standardized rulebook for how automotive software should be written and structured so different parts can talk to each other.
Correct. Marcus noted that you can have the best individual Rust-based software stacks in the world, but if they don't integrate seamlessly via these standards at runtime, you don't have a platform, you just have islands of technology.
And to bridge those islands, the industry is moving heavily toward virtualization.
Yeah. Harshad Butata noted how companies like Qualcomm and Google are virtualizing software-defined vehicles to decouple the software from the hardware lifecycles.
So they are running consistent automotive software across both physical hardware and virtual system on chips, or SOCs.
Right, and a SOC is essentially an entire computer system, the processor, the memory, the graphics, packed onto a single microchip.
So virtualization means they are creating a digital ghost of that physical hardware in the cloud.
Yes. That way, developers can test and innovate at the speed of software. They don't have to wait months for a new physical microchip to be manufactured and installed in a test vehicle.
They just test the code on the virtual chip, and when it works, they push it to the physical car. But hold on, I have a question about that. If everything is virtual, and we are constantly updating these complex systems over the air, doesn't that make the car incredibly fragile? I mean, we've all had our smartphones completely bricked by a bad iOS or Android update.
Oh, for sure.
So how does an automaker scale a constantly updating system across millions of vehicles without triggering a mass outage on the highway?
Well, standardized platform continuity is really the only way to manage that kind of complexity without it collapsing. You don't build a bespoke software architecture for every single car model anymore.
Right. That would be a nightmare to maintain.
Exactly.
Yeah.
Peter Bosch posted about exactly this regarding Cariad, the software subsidiary for Volkswagen Group. They are scaling their software platform from high-end premium vehicles all the way down to the entry-level Skoda Epic.
So they use the same foundational architecture across the entire fleet.
Yes. When you use the same architecture, you aren't managing a million different fragile webs. You are managing one robust, heavily tested platform that just turns certain features on or off depending on the car it's in.
It's the difference between artisanal, custom engineering for every single car and building a true, scalable factory for software.
Exactly.
But that leads us right into the biggest hurdle of all. If this virtualized, continuously updating architecture is the vehicle's new nervous system, how on earth do we validate it? How do we prove an AI is safe enough to let it drive the car itself?
That is the trillion-dollar question, and the actual bottleneck holding everything up might surprise you.
Here's where it gets really interesting. Sandeep Corey shared an incredible insight. He pointed out that sensor fusion is basically an architecturally solved problem now.
Wait, really? The hardware's fully there.
Yeah, the physical act of combining cameras, LiDAR, and radar into a unified 3D view of the world, the hardware can do it. The real bottleneck is AI perception validation.
Ah, that makes sense. Because traditional automotive safety is built on deterministic hardware equations. You test a mechanical brake line thousands of times, and you can calculate exactly when it will fail due to wear and tear. But when your sensor is actually a learned neural network interpreting pixels, standard safety equations fail. An AI doesn't have a mechanical wear rate. It gives a probabilistic output.
It says, I am 98% sure that is a stop sign and not a pedestrian wearing a red shirt.
Right. And the safety tool chains for regulatory approval simply aren't built to handle probability like that.
Which creates what George Pasco refers to as the SOTEF validation gap. And SOTEF stands for safety of the intended functionality.
His post was fascinating. He broke down the sheer mathematical impossibility of real-world testing.
The numbers are staggering. To prove statistically that an autonomous vehicle is safer than a human driver, you would need to drive it for roughly 14 billion kilometers. Let's just dwell on that number for a second.
It's mind-boggling. If you drove a single car 24 hours a day at highway speeds, it would take you roughly 16,000 years to hit 14 billion kilometers.
So you literally cannot drive your way to safety.
No, you can't. By the time you finish, the hardware and software would be decades obsolete.
So if real-world driving can't solve it, how do they validate the AI?
High-fidelity digital twins. Pasca explains that the industry has to rely on simulation, and these aren't just high-end video games. They are physics-accurate reconstructions of reality.
They use procedural generation to simulate thousands of chaotic edge cases, right?
Exactly. They can program a scenario where, say, a pedestrian wearing a stop sign t-shirt is walking a dog on black ice with blinding sun glare hitting the camera lens.
The ultimate nightmare scenario for a camera.
Yes. And they simulate these ultra-specific, chaotic moments 10,000 times an hour on massive GPU clusters to find the exact statistical boundary where the car's AI perception fails.
Wow. You are essentially using one AI in a server farm to aggressively interrogate another AI in a virtual car.
It is just mind-blowing scale.
It really is. But, there's another side to this safety coin, and it's less about the car making an innocent mistake and more about malicious actors.
Yeah.
Let's talk cybersecurity.
Oh, this is a massive issue.
Definitely. I was reading a post by Antonio Gonzalez-Burgueño about something called VEX files, vulnerability, exploitability exchange files. In the modern software supply chain, automakers get flooded with thousands of automated vulnerability alerts every single day.
Yeah, it's a constant barrage.
And a VEX file is basically a technical document that says, yes, this flaw exists in our code, but here's exactly why it cannot be exploited in our specific vehicle's architecture.
But Burgueño warned that these VEX files cannot just be bureaucratic shields.
Right, companies can't just use them to avoid the cost of patching and testing. They must be deeply technically defensible.
And that ties directly into a sobering point made by Michael Entner-Gomez. He emphasized that in a connected vehicle, any over-the-air update channel or gateway module is a massive attack surface.
Because once you have a software-defined architecture, you aren't just driving a mechanical vehicle anymore.
Exactly. You are driving a 2-ton computer that someone else can reach remotely. The exact same infrastructure that seamlessly pushes your new infotainment update or fixes a bug could, under the wrong conditions, be compromised by a bad actor.
When you put it like that, it really changes how we should view the data these cars generate. I mean, for years, the narrative was that vehicle data was a gold mine, something to be harvested and sold to advertisers or third parties.
Right, the new oil.
Exactly.
Yeah.
But considering the safety and cybersecurity risks, it sounds like we need to stop thinking of vehicle data purely as a gold mine to be sold and start treating it like a continuous EKG monitor for the car's health and security. The data's primary purpose has to be diagnosing and protecting the host organism.
I think that analogy is spot on, actually, and the industry data backs you up. Leslie Clavin highlighted a new report showing that OEMs are officially shifting their priorities.
So they're finally focusing on smart diagnostics and predictive maintenance.
Yes. They've overtaken data monetization as the top global priorities for automakers. They are realizing the true value of the data isn't in selling it. It's in using it to spot anomalies, stop cyber threats, reduce costly recalls, and ensure that the vehicle actually gets better and safer over its life cycle.
So what does this all mean?
Yeah.
We've gone on quite a journey today. We started inside the cabin, looking at how agentic AI is turning the dashboard into a context-aware companion.
And then we dove under the hood to see how legacy organizational silos have to be torn down.
Right, to build standardized, virtualized software platforms using safer code like Rust. And finally, we looked at the sheer mathematical impossibility of real-world validation and the massive simulation and cybersecurity shifts required to keep these two-ton computers safe from edge case accidents and active threats.
This raises an important question for you to consider, though. As vehicles become these continuously updated AI agents, monitoring our driving habits, our calendars, and the environment around us in real time, at what point does the car stop being a piece of hardware you own and start becoming a personalized digital entity you subscribe to?
That is a deep thought.
And as that boundary blurs, how will that shift redefine personal privacy and insurance liability in the coming decade?
If you enjoyed this episode, new episodes drop every 2 weeks. Also check out our other editions on electrification and battery technology, future mobility and market evolution, and commercial fleet insights. Thank you so much for joining us on this deep dive. Keep questioning the road ahead, and don't forget to subscribe so you never miss an update.